Okay, let's have an application of the mixing. Okay, here a tank contains 200 liters of fluid in which 30 grams of salt is dissolved. Brine containing 1 gram of salt per liter is then pumped into the tank at the rate of 4 liters per minute, and the solution, well stirred, is pumped out at the same rate. Find the amount of salt in the tank at any time and find the amount of salt after 15 minutes. Now this is the formula that we're going to use. If we let X be the amount of salt in the tank at any time, then the rate of change of the amount of salt in the tank is equal to rate that is coming in minus rate that is coming out. Now this is the diagram. Okay, now that you see that initially uh, there's 30 grams of salt, okay, containing 200 liters. Now, okay, what is coming in is 4 liters per minute with a concentration of 1 gram per liter of salt, and what is coming out is 4 liters per minute. And of course, this will be mixed already, and if we assume that the variable amount of salt in the tank is X, then the amount of salt in the tank, okay, the concentration of salt in the tank is equal to what? Is equal to this one, X over 200. Why 200? Because you see that 4 liters per minute come out, and also 4 liters per minute, rather 4 liters per minute is coming in, and 4 liters per minute is coming out. So basically there is no what? There is no increase or decrease of volume at any time. So the amount of volume is what? Is always 200 liters. What will just be changing here is the amount of salt in the tank, which is X. Okay, so okay, this is our formula. Okay, dx dt is equal to the rate that is coming in minus rate that is coming out. Okay, look at the unit. Our dx dt, our x is in grams and our time is in minutes. So basically, the unit of R in and R out must also be in grams per minute. And you see, okay, this is our dx dt is equal to, how do you get the unit in grams per minute? Okay, you see, you just multiply this one. Okay, multiply this one, 1 gram per liter times 4 liters per minute. You see that, what? You see that this will cancel out, the liter there will cancel out, and you will have grams per minute, and then subtract that to the amount of salt in the tank is what? At any time is X. So the concentration of salt in the tank is X divided by its volume, which is always constant, which is X over 200, multiplied by the amount that is coming out. This is 4 liters per minute. Okay, so you see that this liter and liter will cancel out, and the unit will still be in grams per minute. You see, this is grams per minute. So we have a consistency of units now, and we have, okay, our dx dt will be what? 4 minus 4x over 200. This can be simplified into dx dt equals 4 minus x over 50. Okay, transfer that x over 50 there. That is dx over dt plus x over 50 equals 4. Now you see, this is a linear differential equation. Okay, so our integrating factor, or so our p of t is 1 over 50 and q of t is 4, and our integrating factor is of course e to the integral of p of t dt, that is e to the integral of p of t, that is 1 over 50 dt, that is e to the 1 over 50t, and substituting in the general solution of the linear GE, this is integrating factor times x is equal to the integral of the integrating factor times this 4 here, dt. Integrating, okay, so how do you get this 200? Okay, that is simply 50 times 4, okay, to balance the integral. So that's 200 e to the 1 over 50t plus c. And if you solve for x, xt is 200 plus c e to the minus 1 over 50t. Now you have to determine the value of c based on the initial condition given. Okay, we have to solve for c. Now you see when t is 0, x is 30. So you plug it in this equation there. You can find c. You will have what? Here, 30 is 200 plus c e to the, okay, this is already 0. Then you can get c is negative 117. And your x of t now is equal to, okay, you plug it in our original equation. This is our equation, you know already that value of c here. So c is negative 170, and therefore x of t is 200 minus 170 e to the minus 1 over 50t. And then you can solve this, find the amount of salt after 15 minutes. Then after 15 minutes, you just have to plug t is 15 there. That's 200 minus 170 e to the minus 1 over 50 times 15 gives you 74.06 grams. Okay, let's have another problem, but this time it's different from the previous example. The rate that is coming in is different from the rate that is coming out. Look at the problem. Brine containing 3 pounds per gallon of salt enters a large tank at the rate of 2 gallons per minute, and the mixture well state leaves at 1.5 gallons per minute. Okay, look at this. The rate that is coming in is 2 gallons per minute, and the rate that is coming out is 1.5 gallons per minute. So this is now different. If the tank contains initially 100 gallons of water, okay, with 4 pounds of dissolved salt, okay, find the amount of salt in the tank after 4 minutes. So, okay, the amount is, this is a diagram. The amount that is coming in is, the concentration is 3 pounds per gallon, okay, at 2 gallons per minute, and the amount that is leaving is, this is not G but rather pounds. So let's change this to pounds. That is pounds, and then the amount, this is gallons. Okay, right, that is gallons. So look at the diagram. Okay, the amount that is coming in, the concentration is 3 pounds per gallon at 2 gallons per minute, and the amount that is leaving, the concentration, of course, okay, the, okay, let's say that this will be variable now. Let's say that the of uh, amount of salt in the tank at any time is x, that is x. Okay, that's variable. And then the concentration after 30 minutes will of course be what? Will of course be x divided by the volume, that's 100 gallons, okay, plus the amount that is coming in is 2 minus the amount that is coming out is 1.5 multiplied by t. Basically, the units is in pounds per what? Pounds per gallons here, times the amount that is coming out is 1.5 gallons per minute. Okay, so your setup now is the rate of change of the amount of salt that is remaining in the tank is the rate that is coming in minus the rate that is coming out. We will have to be consistent with the units here. Okay, this is what? This is 3 times 2. So basically your unit will cancel out there, that gallon and gallon. And this is not, okay, we changed this already to what? we changed this already to pounds. Alright, that is pounds. Okay, so over that 100 plus, okay, 100 plus 2 minus 1.5 t times 1.5. This will be our setup. Look at how we set up this. This will be x divided by the volume at any time times the amount that is coming out. Be, make it sure that we will have what? Consistency of the units. By the way, this is not liters per minute, but this is in gallons. So that gallon and gallon there will cancel out because T is in minutes. So basically the unit of this is in pounds per minute. The unit of this is in also pounds per minute. Okay, and the unit of this is also in pounds per minute. Simplifying the problem, this is what? dx dt is equal to 6 minus 1.5x over 100 plus 0.5t. Okay, uh, transfer that 1.5 over 100 plus 0.5t there, and factoring x, this is dx dt plus x times 1.5 over 100 plus 0.5t equals 6. And you notice that this is a linear differential equation whose p of t is 1.5 over 100 plus 0.5t and p of t is 6. And we get the integrating factor. This is the e to the integral of p of t dt. That's e to the integral of 1.5 over 100 plus 0.5t. Okay, the integral divide 1.5 divided by 0.5, that is 3. So the integral is e to the 3 ln of 100 plus 0.5t. That's the same as 100 plus 0.5t cubed. This is the integrating factor. And the integrating factor times x is equal to the integral of the integrating factor times 6. So simplifying this, 100 plus 0.5t cubed x is equal to the integral is what? 3. Okay, so this is 3 times 100 plus 0.5t 3 to the 4th plus c. Okay, you see that this integral is what? Okay, this integral is okay, 100 plus 0.5 t raised the 4th over 4. To balance that, there should be a 0.5 and then times 6 there. So basically you will have this one. Okay, this is 100 plus okay, this is 100 plus 0.5t, 100 plus this is 0.5t, 0.5t, okay, divided by what? Divided by 4 times 0.5, that is the balancing, so that is 6. 4 times 0.5 is 2, 6 divided by 2 is 3. Okay, that's why you have this 3 there. So we have what? We have this integral 100 plus 0.5 t cubed x is equal to 3 times 100 plus 0.5 t to the 4th plus c. And then solving for x is 300, 3 times 100 plus 0.5 t plus c times 100 plus 0.5 t raised to negative 3. Now we'll have to find c. Observe that our initial condition is that when t is 0, x is 4. Then we can find c there. Then we have 4 equals 3. Just substitute that value of 0 there, 100 plus 0.5 times 0 plus c times 100 plus 0.5 times 0 to the negative 3, and just substituting solving for c. C is negative 2.96 times 10 to the 8, and then you can plug it to this equation again, this one. So this is, so here now we now have the function or the model x of t is 3 times 100 plus 0.5 t plus negative 2.96 times 10 to the 8 times 100 plus 0.5 t raised to the negative 3. And when t is 4 now, okay, what is being asked here is find the amount of salt in the tank after 4 minutes. When t is 4, just plug 4 there in this equation here. So plug 4, 3 times 100 plus 0.5 times 4 minus 2.96 times 10 to the 8, 100 plus 0.5 times 4 is the negative 3, and then you will have negative, rather 27.0726 pounds of salt. Okay, that will remain in the tank after what? After 4 minutes.